Mars is a world of silence, a planet shaped by time, dust, and extremes. Its surface is cold, dry, and unforgiving, yet every ridge and crater tells a story billions of years old. Long before humans ever dreamed of spaceflight, Mars captured our imagination. Ancient civilizations saw it as a wandering red star, a symbol of war, fire, and mystery. But beneath its rust-colored surface lies a far deeper story, one written not in myths, but in rock and time. For centuries, astronomers studied Mars through telescopes. They mapped bright regions and dark patches, speculating about oceans, deserts, and even intelligent life. Yet one of the greatest geological features in the solar system remained hidden. Not because it was small, but because it was far too large. This immense structure rose so gradually from the surrounding plains that early observers failed to recognize it as a mountain at all. Its slopes were too gentle. In 1971, NASA's Mariner 9 spacecraft entered orbit around Mars. It was the first spacecraft to orbit another planet. At first, Mars was hidden beneath massive global dust storms. But as the dust slowly settled, something extraordinary emerged. Images revealed a colossal structure rising above the surrounding plains, a shadow stretching across the Martian surface, larger than entire regions of Earth. This immense structure was named Olympus Mons, Mount Olympus, a fitting name for a mountain worthy of the gods. Olympus Mons is the tallest volcano and the largest mountain ever discovered in the solar system. It rises approximately 22 kilometers above the surrounding Martian plains. For comparison, Mount Everest rises just under 9 kilometers above sea level on Earth. Olympus Mons rises nearly 3 times higher than Mount Everest. If Everest were placed on the slopes of Olympus Mons, it would appear insignificant, a small bump on an endless incline. The summit of Olympus Mons extends into Mars' thin atmosphere, where air pressure is only a fraction of that on Earth. At the top, the sky would appear darker, fading quickly into black. Yet despite its immense height, climbing Olympus Mons would not feel like scaling a steep mountain. Its slopes rise so gently that the ascent would be barely noticeable. Olympus Mons spans more than 600 kilometers across its base. That is roughly the distance from New York City to Chicago. Standing on its slopes, you would not see a dramatic peak rising ahead. Instead, the mountain would stretch endlessly toward the horizon. In fact, the curvature of Mars itself would hide the summit from view. You could walk for days without realizing you were climbing the largest mountain in the solar system. To understand why Olympus Mons exists, we must first understand why Earth cannot produce such a mountain. Earth's crust is broken into massive tectonic plates. These plates float on a semi-molten mantle, constantly moving over geological time. When magma rises through Earth's crust, it creates volcanoes. But as tectonic plates shift, those volcanoes are carried away from their magma source. This movement limits their growth. Mars tells a very different story. Unlike Earth, Mars has no active plate tectonics. Its crust is essentially locked in place. When magma rises from deep within the Martian mantle, it erupts at the same location again and again. Over millions, even billions of years, lava accumulates layer upon layer. Each eruption spreads thin lava flows across vast distances. Olympus Mons did not form in a single eruption. Its creation was a slow, patient process that unfolded over hundreds of millions of years. Each eruption added a new layer of basaltic lava. These flows were not explosive. They were calm, steady, and persistent. Lava traveled great distances before cooling, spreading evenly across the landscape. Olympus Mons is classified as a shield volcano. This type of volcano is built almost entirely from fluid lava flows. On Earth, shield volcanoes include Mauna Loa and Kilauea in Hawaii, but even these giants pale in comparison to Olympus Mons. Shield volcanoes are named for their shape: broad, rounded, and gently sloping. At the summit of Olympus Mons lies a massive caldera complex. It spans approximately 85 kilometers across, larger than many cities on Earth. This caldera is not a single crater, but a collection of overlapping collapse pits, each formed when a magma chamber beneath the surface emptied, causing the ground above to collapse. These collapses occurred repeatedly over time, recording the volcanic history of the mountain. Each layer tells a story of eruption, collapse, and renewal. Long ago, lava flowed across Olympus Mons like rivers of fire. Under Mars' low gravity and thin atmosphere, lava behaved differently than it does on Earth. It traveled farther. It cooled more slowly. It spread across enormous distances before solidifying. When these lava flows finally cooled, they preserved the surface exactly as it was. Olympus Mons ends abruptly at its edges. Here, a massive cliff, known as a basal scarp, drops nearly 8 kilometers to the plains below. This cliff is among the tallest known escarpments in the solar system. Its sheer height marks the boundary where the immense weight of the volcano fractured the surrounding crust. Standing at the base of this cliff, the summit would be invisible. As Olympus Mons grew, its immense mass placed enormous stress on the Martian crust. In some regions, this stress caused sections of the volcano's edges to collapse outward. These collapses produced massive landslides, reshaping the mountain's perimeter. Entire sections of terrain may have shifted by kilometers. These features reveal the limits of even the strongest planetary crusts when confronted with geological giants. Earth constantly reshapes itself. Wind, water, ice, and life erode mountains and fill valleys. Mars is different. Its atmosphere is thin, its water long gone. Olympus Mons is often described as a fossil volcano. Its layers record a history of eruptions stretching across vast spans of time. By studying these layers, scientists can reconstruct the volcanic and thermal history of Mars. Each flow provides insight into the planet's interior and its long-term evolution. For many years, scientists believed Olympus Mons was extinct. Its eruptions seemed long finished. But recent studies suggest otherwise. Some lava flows appear to be only a few million years old. In geological terms, that is extremely recent. Mars may not be a dead planet. It may simply be dormant. If Olympus Mons were to erupt again, it would transform our understanding of Martian geology. It would prove that Mars still has a living, dynamic interior beneath its frozen surface. One day, humans may stand on Mars. When they do, Olympus Mons will dominate the horizon. It will not appear as a single peak, but as an entire landscape rising gently toward the sky, a reminder of the immense forces that shaped this world. Beneath Olympus Mons lie vast lava tubes. These natural tunnels could provide shelter for future explorers. Protected from radiation, extreme temperatures, and dust storms, they may one day house humanity's first Martian settlements. Climbing Olympus Mons would take weeks. There are no steep ascents, only endless slopes stretching toward the horizon. The challenge would be endurance, navigation, and survival in an alien environment. From the summit of Olympus Mons, Earth would appear as a distant blue dot, a reminder of how far humanity has traveled and how small our home truly is. Olympus Mons teaches us that planets evolve in different ways, that size, gravity, and time shape worlds uniquely. It challenges everything we thought we knew about mountains. This mountain is more than rock and lava. It is a monument to deep time, a record of patience, persistence, and planetary power. As we continue to explore Mars, Olympus Mons stands silent, a witness to a planet's past and a guide to its future. In the vast universe, some mountains are not meant to be conquered, but understood. Olympus Mons reminds us how small we are and how extraordinary the universe can be. If you enjoyed this video, please like the video, share your thoughts, and subscribe. For more such informative videos, visit the Daily Science Journal channel page. Thank you.